Okay, we left off last time looking at Darwin and kind of his contributions to the idea of evolution. We talked a little bit about the different ways of defining the word evolution, some of the different views of evolution, and kind of Darwin's contribution where he developed his main ideas about evolution. And now we want to look at some other figures actually that were around prior to Darwin that kind of influenced some of these influenced Darwin, and they had different ideas about evolution. Um, and we can go all the way back to the Greeks with this. There were ideas of life coming from other forms of life all the way back to Greek perspectives. Um, even Aristotle had views. His views were more that species were perfect and did not change um, at all. So Aristotle viewed the perfect unchanging. We know that's not correct. We know that there are some changes that occur. We talked about macro and micro evolution in the last podcast, and we know microevolution is observable. We can see that. So we know that species aren't perfect without some ability to change. Um, but there were other figures that play an important role in evolutionary discussion, and some of these figures are biologists, but some of these are geologists. Geology plays an important role when we look at large-scale historical evolution, primarily because that's where our fossils are found. That's our direct evidence we have when developing ideas about historical, or I use the term historical evolution or macroevolution stuff that we are talking about in the past. Um, Fossils is what we have. And so geology plays a very big role. There's two kind of key figures when you talk about geologists and their input about evolution in the past, and that is Charles Lyell and George Cuvier. Lyell, oh, excuse me, Lyell wrote a book called The Principles of Geology, and he basically came to believe that the Earth and the layers of the Earth, called strata, were laid down very, very slowly over long periods of time. And this view of Lyell came to be known as uniformitarianism. Uniformitarianism. So Darwin read a lot of Lyell and his perspective. But another geologist was also had a kind of a different perspective on geological features of the Earth, and that is George Cuvier. Cuvier is considered the father of catastrophism. And as that term kind of implies, it's the view that geology and geological formations happen through catastrophes. Um, in this view, the fossils, rocks, and layers and everything form rapidly um, due to some kind of geological disturbance or natural disaster, floods, earthquakes, things like this. Most of the strata can be recognized as these periods of uh, kind of rapid catastrophic events. All right, so these two guys basically looked at the same thing and came up with two different perspectives about the strata and the layers of the Earth. They both had influences in biology. Okay, another figure that we want to look at, your book mentions when it comes to kind of early ideas of evolution, is a guy named Lamarck. Jean-Baptiste Lamarck. He had kind of a view of evolution, and his view is that the features that we see in organisms came about through use or disuse and his perspective of this is now kind of coined in the phrase inheritance of acquired characteristics. Now, his perspective is almost always associated with the giraffe. So you see the giraffe, and it's talked about with his view. And in this view, the giraffe that we recognize today, which has a long neck, which is different from most other animals that just have average sized necks. So the idea is that this feature came from somewhere, that probably this animal had an average or normal sized neck at some point in the past, and hence our figure right here showing this theoretical animal right here. So we don't really have any direct evidence this animal existed. But anyway, the theory is that the long neck probably came about from this theoretical animal reaching up and grabbing leaves off of trees, and then those leaves would be gone in the next generation. So the next generation would have to reach up higher and so forth. Every generation it would get longer and longer. So he would use that feature and increase it during his life and then pass that trait on to its offspring. Now, Lamarck's an important figure for our ideas about evolution, but he was wrong, and we know he was wrong. Mendel came about later and showed us how traits are passed on to offspring. So we got our laws of segregation that Mendel developed, and so we know that traits are passed on in a very uniform way, and you can't enhance a trait and then expect that enhanced trait to be passed on. So we know that Lamarck was wrong, but still had important influence about traits and the going from one generation to the next, and so important figure, but he was wrong about his ideas about traits. Okay, so next we want to look at, in this podcast, we're also going to look at the evidence for evolution. As I mentioned before, when we are talking about historical evolution, we're talking about stuff in the past, the fossils are going to be our main evidence. All right, so if we're going to court and we want some physical evidence to prove something, fossils is really all we have. That's all we have is fossils. There's some other things that your book uses and that are used to promote views about historical evolution, but the only direct physical evidence, these are more lines of logic, but the only direct physical evidence we have is fossils. So fossils include a lot of different things we show here, petrified things, imprints, these dinosaur tracks, skulls and bones of organisms that have died in the past, actual organisms that have been trapped in some substance, ice, amber. So any kind of imprint or piece of an organism, bone that is left from that organism would be considered a fossil. All right, so in figuring out what these fossils mean, we can say something about where they're found in the earth. So in the earth, this diagram kind of shows here the strata. So the strata are the layers of the earth. So if you look at this figure here, here's the Grand Canyon, and you can see in the Grand Canyon these different colors or bands here within the canyon, and those are strata. Those are different types of sedimentary rock, and so generally geologists say if you find fossils down here lower in the strata, then that animal or that whatever animal is represented by that fossil died longer ago than the animals or fossils that are found up here higher in the strata. And that would kind of fall along with Lyell's uniformitarianism view that they were laid down very slowly over long periods of time. And this is generally accepted by geologists. There have been some times when fossils are found not where they're expected to be found, so certainly catastrophes play at least some role in mixing up these fossils. But generally speaking, it does seem to be the case that older things are lower down in the strata, more recent things are up near the top. So, makes sense. So that is kind of how we interpret what these fossils mean. Now we don't have, often the fossil record is considered incomplete, or it's called incomplete by biologists because we don't have a fossil of every single thing that ever lived. So we try to make sense of the fossils that we do find. And by making sense, we're talking about, is there a connection between this animal and that to tell a story about what has happened in the past? If they are, then that would be considered a transition fossil. So your book talks about that. This is an example of one that is sometimes considered a transition fossil. This animal right here, Basilosaurus, a whale-like creature, had back flippers, or at least in its partial structure of its skeleton that has been found, it had some structure that looks like a back flipper. All right, so one scenario is that this back flipper allowed this animal to come out of the water and walk on land. So maybe it's a transition animal between an aquatic mammal and a land mammal. So there's different perspectives about this and some transition. Certainly Darwin wanted to see, he was a fossil collector, he wanted to see a lot of transitions. He wanted to see more than we have found. Darwin actually had a quote in his book, The Origin of Species, that stated that fossils didn't really give good support to his view of large-scale evolution or historical evolution. His quote is that fossils were the gravest objection against his theory. So he didn't really see fossils giving a lot of support to his theory. So we have other types of transitions. A very common one is like Archaeopteryx. It is sometimes claimed to be a transition organism as well, in between birds and reptiles. So one thing we do want to say before leaving this podcast about fossils is looking at fossils in the past, we can see when large amounts of fossils appear in certain strata, or when certain animals are more prevalent in certain stratas. And one very important strata or layer in the earth is one that geologists refer to as the Cambrian strata or the Cambrian period. And this one is very important because we see most of the major animal forms appearing abruptly in this layer of Earth. And this is one of the reasons Darwin had a kind of a problem with fossils. This is Darwin's prediction of a slow, gradual change over time. And the Cambrians, this is a fossil representation of when they're recognized, this line representing the Cambrian period. So it doesn't really match with Darwin's slow progression of animals appearing in the fossil record. This is sometimes referred to as biology's Big Bang because most of our animal forms appear kind of abruptly in this one time frame in historical past. Okay, we're going to stop here, and then we will pick up in the next podcast talking about more lines of evidence that's used to support macroevolution.